Welcome back. All right, since stratigraphic layers for the most part are sedimentary, but we can have igneous or metamorphic layers or strata. But sedimentary rocks, as I mentioned a number of times in the past, for the most part, the sediment that was that was lithified to create eventually those sedimentary rocks, for the most part, is deposited in the shallow parts of the ocean, or the coast, or just off the coast. So let's talk about coastal and marine environments. So there's two kind of events that happen near the coastal areas and the marine areas that are recorded in rock records, and definitely in the sedimentary rock strata. And again, sedimentary rocks do a heck of a good job of telling the story of Earth. So one such aspect is something called a marine transgression. So it means a marine transgression occurs when sea levels rise. This could be due to climate change, global warming events that might melt any ice caps or glaciers, that water going into the oceans, rising sea levels. Due to plate tectonics, things moving around, that could cause transgressions in certain areas. But when that happens, when sea levels rise during a marine transgression, the shoreline comes further inward. All right, so imagine this is the shore, and if we're looking at it from the side, here's the water. As sea levels rise, right, the shoreline goes landward. It goes more in towards land. Seaward is the other way. Landward is kind of in towards more land. So when a transgression occurs and the water rises, the shore moves landward. When that happens, all the environments that are kind of paralleling the shoreline, reefs, shallow reefs just below the surface, beaches, all of that migrates landwards as well. So as the water rises, the beach, which was here, now the beach is here. Any reefs that are just below the surface, as that water moves upward, then so does the reefs. And we're talking about sea level change. We're talking, centimeters a year, not much. So over geologic time, these things happen at a large scale. And when this occurs, each different environment that you have, the beach is kind of moving upward, the reefs moving landward, will then eventually deposit different sediment facies. So we get these now lateral, sideways changing in rock types. So during a transgression, the facies forming offshore become superimposed upon facies deposited in nearshore environments. So let me show you a little bit about what I mean here. Again, during a transgression, the facies forming offshore become superimposed facies depositing in nearshore environments. So again, so closer to the shore, you have sand being deposited, which eventually turns to sandstone. You have silt being deposited, which eventually turns to mudstone, siltstone, or shale. And then you have calcium carbonate being deposited, which eventually turns into limestone. But again, during a transgression, as the sea level is rising, the facies forming offshore, limestone, become superposed upon facies deposited in nearshore environments, so sandstone. So the stuff from further out is now vertically above the stuff that was closer in. So for instance, if I look right here, all right, I have sandstone, shale, limestone. The stuff that was further out is now vertically higher up. And as you move inward, the rock types get younger. So for instance, the shale is here, this is the oldest, and then the youngest kind of not only vertically moves up, but also inward during a transgression. And so what we see happening here horizontally is also reflected vertically. More on that in just a second. But to imagine what's going on here, just block these two layers out. Imagine at a certain time the water level was right here. We have limestone, shale, sandstone. Then the sea level rose to here. And so those environments, for instance the beach, where sand is deposited, moves even further inward. So sandstone, shale, limestone. And then sea levels rise again to this level. Right? And so we have sandstone, shale, limestone. Sea levels rise again, so the sandstone will continue to move landward, or indicate sediment deposition landward. Same thing with shale, same thing with limestone. So what we see happening horizontally is what we also see happening vertically, and that's something called Walther's law. Not Walter, but Walther. So Johannes Walther noticed, again, the same facies he found laterally, sideways, also presented themselves in the same sequence vertically. I mean, it sounds kind of obvious, but someone had to say it. So going from the original surface of land, we have sandstone, shale, limestone. Well, same thing here. From the original surface, sandstone, shale, limestone. Go figure. So what this is now referred to as Walther's law. What we find the facies horizontally are also reflected vertically in a vertical sequence. And this applies to both transgressions, sea level rises, as well as regressions, which we'll talk about in a little bit. So, Grand Canyon, great place to see marine transgressions, places that indicate sea level has rose. Now, we're looking at vertical strata. We see sandstone, shale, limestone, but vertically represents also what we would have seen horizontally. So we can connect those two. That's Walther's law. So we have, in just this particular sequence, in the Tonto group, a group is like a number of rocks that were kind of deposited around the same time. They're still different, but they're kind of this event. And the Tonto group represents a transgression event. We have the Tapete sandstone, the Bright Angel shale, and the Muav limestone. Wait a minute. Sandstone, shale, limestone. Let me come over here. Sandstone, shale, limestone. Oh my gosh, that represents a horizontal inundation of sediment. That represents a vertical sea level rise going upward. That is a marine transgression. So when we're looking at layers of the Grand Canyon, and this is just a few layers of the Grand Canyon, we can look at the sequence of the rocks themselves, and then from that we can extract, well, what was happening to sea level during this time? Oh, I see. Sandstone, shale, limestone. Oh my gosh, that indicates a sea level rise. And in fact, there's a number of different marine events in the Grand Canyon that represent both transgressions, sea level rises, but also regressions, where the sea level also dropped. So, marine regression. So during a marine regression, that's the opposite of transgression. Sea levels fall with respect to the continent. Maybe global cooling caused glaciation, so now water's got to come from somewhere, and so that water coming from the ocean into the atmosphere, turning to snow, compacted into ice, creates ice caps and glaciers, so sea levels are falling. And then again, plate tectonics, moving things around, things can happen. Oceans, basins change, uplift can occur, etc. So in this case, environments paralleling the shore migrate seaward. So the beach kind of moves seaward, out, all right, because the water level is falling. So all of this stuff, these environments are moving seaward. And in this case, the vertical sequence of nearshore facies are now overlying rocks that were kind of more offshore facies. So what this looks like through time, so let's say this is what it looks like at one point. Here's the sea level. Sandstone, shale, limestone is created from the sediment that's deposited in these areas. Well, the sea levels drop, and you can see kind of the sandstone, shale, limestone making its way further out. Sea levels further drop. Same thing happening. So the opposite vertical sequence is what we have here. All right. So the opposite vertical sequence is what we now see. So in this case, instead of going sandstone, shale, limestone, we go the opposite. If we have limestone, shale, sandstone in a vertical sequence, that indicates a marine marine regression. Sea levels are falling. So depending on how the rock layers that we see vertically are going on, we can figure out, oh my gosh, the ocean environment that helped to deposit the sediment that eventually created these rock layers, if it's in a particular order, oh my gosh, sea levels are rising, sea levels are falling. Sedimentary rocks do a good job of telling the story of Earth. They're not all that much to look at, but they do a good job of telling the story of Earth. Since the late Precambrian, So over 500 plus million years ago, there's been 6 major marine transgressions followed by regressions that have occurred in North America. These have been in different places as well, but at least there's been 6 major ones that have covered North America. These produce different rock sequences bounded by some sort of unconformities, typically, that provide structure to a large amount of geologic history of the U.S. through the Paleozoic and Mesozoic, and somewhat into the Cenozoic as well. Again, when we're looking at these transgressions and regressions, we're talking about shoreline moving at, a few centimeters per year, like every year, this much. So, but over geologic time, it begins to add up. You also get, it's not just up and down. Sometimes you get little fluctuations of sea level back and forth, so you get smaller transgressions and regressions with small little reversals that will produce that intertonguing we see between facies sometimes. Okay, this is a cool little chart. So this shows geologic time, as well as in the green, these are different transgressive events, the 6 major transgressive events throughout the U.S. history, all right, throughout U.S. history. So starting down here, all right, this is what at this time, North America, you can see here's New Mexico, Arizona would be right around here. Here's where North America is actually right by the equator and turns sideways. But you can see the extent of it. Now let's fast forward to the middle of the Sauk transgressive event. You can see, all right? So that was about 500 million years ago. Fast forward to the end of that event. Did I miss something? Oh no, that's the Sauk. Excuse me. Hey, what's happening? Hold on. Sorry for the interruption. Sorry, that's my fault. Let me try this again. So we have around 550 million years ago at the beginning of the Sauk, and then come on now. And then at the height of it, the water transgressed, came in. At the end of it, it started to recede. These are all sand depositions, so you can see how sand was deposited, eventually forming sandstone. And then the Tippecanoe, water's back in. And then at the end of the Tippecanoe, water's back out, regressed. So water level at the Kaskaskia, back in. At the end of the Kaskaskia, water back out, regression. So at the height of the Absaroka, water back in. At the end of the Absaroka, water back out, regression. So this is the Zuni transgression. The water comes back in. At the end of the Zuni transgression, the water back out. And then the Tejas, some of the water back in, transgression. You can see, for instance, Florida is covered, the coasts are covered. At the end of it, current, this is what we see. All right. Let me go back and just keep an eye on Arizona throughout here. Let's just say in the middle of Arizona. So we'll say Grand Canyon up here. Dry, water. Dryish water. Water for sure. Dry. Water. Maybe some water, maybe a little dry. 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 Water. Dry. Dry. So Arizona has been covered and uncovered a number of times with ocean water via these transgressive and regressive events, which has led, for example, to all the sedimentary layers we see in the Grand Canyon. Okay? It's not that there's ocean there now, obviously, but ocean had to be there at some point for that sediment to be deposited, to build up, compaction, cementation, to cause lithification. And again, what are the causes of some of these transgressive and regressive events? Again, plate tectonics, uplift of continents, that can cause regression. If a continent goes higher, then it seems like the water is falling. Subsidence, if due to plate tectonics the continent sinks, then it would seem like the water level is rising. Again, widespread glaciation can cause regression. You're taking water out of the ocean basins. Rapid seafloor spreading can cause transgressive events. Slower seafloor spreading can cause regressive events. So plate tectonics, climate is kind of the two big things there, really. And all of these are kind of shades of that. All right, let's go ahead and pause there. When we come back, I don't remember what we're going to talk about, but we'll talk about something. Yeah, I'll see you when we get back. See you next time. See you in a few seconds. Whatever it may be.